Hi, my name is Gavin Ruane. I'm a student in CPE 133 Section 7, and this is my Lab 4 submission video. So for this project, students were tasked with kind of augmenting what we've already created in Labs 2 and 3 with the RCA, and in Lab 3 we added a 7-segment display. So this time with the Basis board, we're actually adding a lot of functionality. This is kind of like a simple calculator. First of all, we're going to have the same two inputs, the A and B, so that will be represented by 4 switches representing 1 bit of a binary number. But we're also going to have another switch over here, I believe, but we'll see this in the later part of the video, that will determine whether we're subtracting or adding. So we're kind of adding like a whole new functionality to this project. Additionally, we're going to have an LED that says whether the output is negative or positive. And this leads to our next point, which is that we're going to be using signed binary numbers instead of unsigned. Signed to 2's complement binary numbers. So this means that we can actually add and subtract negative and positive numbers together. So we're really creating a basic calculator, which is pretty cool. We're also going to, of course, be using the 7-segment display, one of them. But you'll notice that not all the time a result will appear, that there might be an empty result. And this is because some negative and positive additions or subtractions will be invalid. So this is one of the modules we had to create for the project, a validity checker. And we'll get to that later, but just to put that out there so you're aware of why some results will not display on the screen. And of course, this is in hex output, so we're going to be seeing these in hexadecimal outputs. So there we go. That's it for this part of the video. Stay tuned for truth tables and any other relevant data, and of course the test cases. Thanks. All right, let's get into our test cases. So before we start, I would just want to go over a few things about how the Basis 3 is actually working for this Lab 4 demonstration. And I also just want to apologize. As you can see, there's already check marks and I'm 100% here. My phone decided to just not record the audio. So we're just going to have to do it again. And as you can see, we've already passed, but I'm going to demonstrate once more. Okay, so one thing I want to point out real quick is that this leftmost switch is a new input for us, and this is the calcsub input or subtract. So if it's in the 0th position, it's going to be adding. If I flip it up, we're going to be subtracting 2 numbers. So it's kind of like we're adding a whole new function to our simple calculator. Okay, so next, this is the same from the past 2 labs. These 4 switches right here belong to input A, and this is the 3rd, 2nd, 1st, and 0th most significant bit. And then same concept over here for these 4, just they are corresponding to input B. Okay, and then I also just wanted to note the LED mapping. So we're only going to be using one LED. It's this rightmost LED I'm pointing at right here. And if it's on, in the 1 position, it's going to be negative. If it's off, it's going to be positive. And this is the calcneg output from my System Verilog code in Vivado. And then one more thing, I just wanted to note that we're using signed binary this time, 2's complement. So if it starts with a 1, the binary number, it's going to be negative. If it starts with a 0, it's going to be positive. Okay. Oh, and one more thing too. If I have a question mark over here, so as you can see, I actually solved these myself before going through with the tests. But you'll see that some of them have a question mark. This means that the validity checker and the binary addition rules that we learned about in class had determined that this is not a valid calculation according to our rules. So if we get a question mark, that means that our 7-segment display will turn off and we won't get anything out. This is because this is an invalid result. Okay, let's actually get into the tests. So the first one's already set up for us. We have 0 plus 0 is 0, and that is correct. So I'm just going to add a check mark right here for the second time. 0 plus 5. Okay, 0, 0, 0, 0 plus 0, 1, 0, 1. Positive 5. That is correct. Negative 7 minus 0. So for this one, we're going to flip this one up because we're subtracting, and we're going to do 1, 0, 0, 1. Minus 0. And there's a 7 there, and as you can see, there's an LED lit up right over here. This tells us this is a negative 7, which is exactly what we wanted. Perfect. Okay, now we're just going to do 2 plus 4. So let's see, 2, 0, 0, 1, 0 plus 0, 1, 0, 0. Oh, I didn't do that correctly. I'm subtracting. Positive 6. That is correct. Okay. Negative 2 plus negative 2. Negative 4. Correct. 7 plus negative 4. Let me just double check I did everything correctly. There we go. Positive 3. Okay, negative 6 plus 1. Negative 5. Correct. 5 plus 6. Okay, so as you can see, this is a question mark one in the 7-segment display turned off because this is an invalid calculation for this calculator. Obviously, we could do this ourselves and it would be 11. But with this calculator, it doesn't have that capability just because of the bit size and to complement assigned binary numbers. So we're just not going to display anything. Okay, negative 8 plus 1. And that's another invalid one as well. So nothing should show up. Okay, now here's where we get into some interesting ones. Negative 3 minus negative 5. So I'm going to flip this up first to say that we're subtracting, and then I'm going to do negative 3. So 1, 1, 0, 1. Then I'm going to do negative 5. 1, 0, 1, 1. Positive 2. That's exactly correct. Oh, I skipped this one. 6 minus 5. Positive 1. Correct. Sorry about that. Okay. Now, 2 minus negative 5. So again, we're just going to keep this one up. 0, 0, 1, 0 minus 1, 0, 1, 1. And that is positive 7. That's correct. Okay. Negative 5 minus 3. 1, 0, 1, 1 minus 0, 0, 1, 1. Negative 8. Correct. 1 minus negative 8. And that's invalid. So we don't want anything to show up, and that is perfect. Negative 4 minus 6. Okay, where is that? Let's see. And that one's also invalid, and we're just going to mark that one off because we don't want anything to show up. And as I said before, I've already done this, and it's 100% correct. This calculator works for obviously a limited number of test cases, but it works for the test cases that it can handle. And that's it. Thanks for watching, and stay tuned for the next lab demonstration. Thank you.